Hey guys, Dr. Brown here, and tonight we're working a differential equation, dy dx equal tangent squared x plus y. When you go through your algebra, college algebra, calculus 1 differentiation, calculus 2 integration, ultimately you want to get into differential equations because it's in that course that you begin writing equations relative to real world situations. It's a powerful, difficult class, but it's real. So how do we get better at it? Let's begin practicing a few, okay? All right, so we have the equation dy dx equals tangent squared x plus y. When you have a trig function, in this case tangent squared, but tangent of something, it's tangent of an angle. So I'm going to let theta equal x plus y. Okay. Now my goal here, I need to, since I have a theta, I need to get dy dx as a function of theta. So let me take the derivative of that, d theta, with respect to x. So now I'm going to take the implicit differentiation of the right hand, well, both sides actually. So derivative of x would be 1 plus the derivative of y with respect to x is dy dx. Now you'll notice I have a dy dx there, dy dx here. So let me subtract 1 from both sides. D theta dx minus 1 equals dy dx. So I'm going to replace the dy dx with d theta dx minus 1, and that equals tangent squared theta. Now let me add 1 to both sides. Well, if I add 1, that one goes away, and I put it right here. Well, tangent squared plus 1 is what? Secant squared theta. So that becomes secant squared theta. Now let me separate the variables. I have a theta and an x. Let me get all the thetas on one side. So d theta over secant squared theta equals dx. Well, 1 over secant squared is what? Cosine squared. So that becomes cosine squared theta d theta, and that equals dx. Now then, let's integrate those. So I want to integrate cosine squared. Now you know the tools, UTI, PPL, CQ. Okay, one of these is a power reduction. Oh, actually there's the actual integral right there. Well, let's make believe we didn't see that. Okay, but I can reduce that power by allowing cosine squared, which is 1/2 times 1 plus cosine 2 theta, d theta. That would be cosine squared. Well, that equals the integral of dx. Okay, you know me, I like to separate out, but so I don't lose that 1/2. Integral of 1/2 d theta plus 1/2 the integral of cosine 2 theta d theta. And that equals the integral of dx, which that's just x plus c. Let's go ahead and just get that out of the way. So this would be 1/2 theta plus what? All right, we have cosine 2 theta, right? I'm going to let u equal 2 theta, du equals 2 d theta, du over 2 equals d theta. So let's go back over here. I still have this 1/2 integral of cosine u du over 2. Well, this 2 and that 2 multiply together to give me 1/4. Okay. So what do we have here? 1/2. Oh, that equals x plus c, by the way. 1/2 theta plus 1/4 integral of cosine u, which is sine u, because the derivative is minus sine, the integral is plus sine. So sine u, which sine and u was 2 theta. And that equals x plus c. All right, let's go up here. We have 1/2 theta. Well, theta was x plus y. Plus 1/4 sine 2 theta. I'm running out of room. Let's go right here. We'll go down to right there. So I have 1/2 x plus y plus 1/4 sine 2 theta, 2 theta, which was x plus y, and that equals x plus c. Well, let's get this into a different form. Let's multiply everything by 4. 4 over 2 would be 2x plus y plus 4 over 4 is 1 sine 2 times x plus y equals 4x plus, we'll call it c2, which is 4 times c1. Okay, now we can distribute the 2. So 2x plus 2y minus 4x, I'm going to bring it to this side, which would be minus 2x. So 2y minus 2x plus sine 2x plus y, remember I brought the 4 over, equals c2. Okay? Now, a person might say, well, wait a minute, buddy. How do you know that's correct? Okay? Not to be outdone. We can perform an implicit differentiation on this to see if we can come back and get that derivative. Because this is the general equation that supposedly yielded that derivative. So let's do that. We're going to take the derivative of this thing with respect to x, okay? So this would be 2 dy dx minus 2. Derivative of x is just 1 dx plus derivative of sine 2x plus y. Just think about all of this as just some function, okay? Sine, derivative of sine something, sine u, sine x times g, whatever, is cosine. Cosine of that 2x plus y times the derivative of what's on the inside, which is what? It's would be 2x plus 2y, and we're taking the derivative of that. So the derivative of 2x is 2 plus 2 dy dx. Okay, that good? All right, now then, we have a dy dx terms here. Actually, I need to distribute this. Let me do that. 2 dy dx minus 2. Now, cosine of that angle times 2 would be plus 2 cosine of 2x plus y. And then plus 2, I'll put the 2 on the outside, cosine 2x plus y dy dx. Oh, and when we took the derivative, obviously the derivative of that was 0. Okay, let's collect some terms. I've got a 2. I'm collecting the dy dx terms plus 2 cosine 2x plus y. All of that was my dy dx minus 2 plus 2 cosine 2x plus y. All that equals 0. Now, if I were to move all of this onto that other side, I would be adding the 2 and subtracting this, right? So instead of writing all that down again, I'm going to do this. So equals plus that and minus this. So just make believe I moved all of that to the other side. Now I want to divide this onto the other side. So I have 2 plus 2 cosine 2x plus y. 2 plus 2, yeah. Okay, so all of this would be dividing onto the other side. So now I have dy dx equals this quotient. Let me factor the 2 out. So that would be 1 minus this and 1 plus that. Now, 2's cancel. Now you'll recall, let's say cosine squared x, we'll just say, or theta, equals 1/2. Well, we used it, well, I erased it. We used it earlier though. 1 plus cosine 2 theta. Now, if I multiply that by 2, that cancels, and I just have 1 plus cosine right here. So that's what I have. That's cosine squared. In the numerator, that's sine squared. Because sine squared theta equals 1/2 1 minus cosine 2 theta. Now I'm multiplying it by 2 here. So that 2 cancels, and I just have that term. So dy dx equals sine squared x plus y over cosine squared x plus y. Hey, what is that? Tangent squared x plus y. So we ended up with dy dx equals tangent squared x plus y. So that confirms that this was okay. That was a correct solution. The general equation that if you go back through the derivative, implicit differentiation of that, you get that derivative. Okay, guys, keep studying, okay? Differential equations is, to me, was the real class that put all the math you've taken into reality. It was the reason you were doing all these other things, so that you can build a better tomorrow through your math, okay? Keep studying. We'll talk to you next time. Thanks.